we're going to be looking at graphing linear equations. And before we do so, we need to have some definitions. First, let A, B, and C represent real numbers such that A and B are not both 0. So that means one of them can be 0, but not both of them. A linear equation in the variables x and y is an equation that can be written in the form A times x plus B times y set equal to the constant C. And this is called standard form of an equation of a line. Note, a linear equation ax plus by set equal to c has variables x and y, each of first degree. So that means that the exponential power of x is 1 and the exponential power of y is also 1. The graph of a linear equation is a line. A minimum of 2 points is needed to graph a line, but often we like to get a third or more point. That way we can make sure that the line is graphed correctly. So I'm going to encourage you to do that. And then a line can either be rising, falling, or it could be horizontal or vertical. And we'll be talking about horizontal or vertical more in some following lessons. Reminders, and I'm going to remind you about this quite often in this course, reminders for graphing. Make sure to label the x and y axes and show scale in all 4 directions. Remember, scale is needed so that you can actually identify your points. Without scale, we're just making an assumption of what each value is, and we can't do that. Moving on to our first example for today. In order to graph the line represented by the equation 2x plus 3y equals 6, the first thing that we need to do is to rewrite it by solving for y. This way we can set up a table of values and substitute arbitrary values of x into the equation and solve for the corresponding y values. Now, arbitrary just means any values of x. So starting out with 2x plus 3y equals 6, in order to get y alone, we first need to have the 2x on the opposite side of the equation, and we can do so by using our inverse operations. Since 2x is positive, we're going to subtract 2x. So 3y is equal to negative 2x plus 6. Now, in order to get y by itself, we need to get rid of this 3, and so we're going to undo this multiplication of 3 by dividing all by 3. So we're going to divide all by 3 to give us our y. We're going to divide negative 2 by 3. We have this multiplied still by x, and then we're going to also divide the 6 by 3, which gives us our 2. Now notice please, in this new equation where y is solved for, we have a denominator of 3. So this is going to help us when we go to choose our values of x, because we want to be kind to ourselves so that our work is not difficult. So y is equal to negative 2 over 3 times x plus 2. So the first value that I'm going to suggest that we choose is 0. But then I'd like us to get 2 more points. So I'm going to go to the right of 0 and to the left of 0. But I'm not going to choose 1 and negative 1. I'm going to choose 3. And I want you to think for a moment, please, of why I'm suggesting that we choose 3. I'm also going to have us choose negative 3. And again, why am I having you choose negative 3? So let's get to these 3 evaluations. So starting with 0, y is equal to negative 2 over 3 times 0. But anything times 0 is 0, and 0 plus 2 is going to give us an output of 2. Now substituting 3 in, This is where I'm hoping you can see why I'm suggesting we choose 3. We have -2 divided by 3, but now we're multiplying it by 3, which is then going to simplify the 3's, which gives us -2 plus 2, which gives us an output of 0. So I'm choosing multiples of 3 because the denominator is 3. So that's going to be very convenient for us because then my denominator will cancel and I'm not going to end up with messy fractions. So -2 divided by 3 times -3. The 3's are going to cancel this time, but the negatives will as well because a negative times a negative is a positive. So this gives us 2 plus 2 with an output of 4. Now, as I talked about earlier, make sure you always label your x-axis, your y-axis, and scale in all 4 directions. And because our points are very close to the origin, it is okay for each increment to be a value of 1. So I'm going to go out 5, up 5, to the left 5, and down 5, just so that I can read this without it being too messy. So starting with -3, so 3 to the left and up 4, -3, 4, 0, 2, we'll talk about that point in a little while, and then 3, 0, we'll talk about that point as well. And then as we've talked about before, make sure when you are graphing your lines, you want to respect the fact that these are straight. So I use some sort of straight edge. I'm just grabbing a thicker piece of paper here, and then I line this up, and then arrows to indicate that this goes on forever. And then I'm also going to label this with the original. So 2x plus 3y equals 6 is our equation. Now note, we do have a y-intercept. Remember, our y-intercept is when x is 0. So the y-intercept is 0, 2. And we also have an x-intercept that we can see both from the table and from our graph. An x-intercept is the point on the x-axis. It is also when y is 0. So our x-intercept is 3, 0. And your question, given the equation 3y plus 4x equals 6, solve for y.